Hello everyone and welcome back to another video. And today I have to hold the camera in my hand, at least for this beginning bit, because this box is so big, even if I put the camera arm all the way up, it doesn't fit completely. So, as you can tell by the box, this right here is a Gigabyte Z170X-SOC Force LN2. In completely original packaging, with all the accessories. Like, this thing is in mint condition. It's used, but it's in mint condition, like really, really good condition. And sadly, this isn't mine. I would love to keep this. This belongs to Spicer, or Old Spice, who's a friend from the JackNet RGB Discord. And like, as I've been doing for FZR and Deeper, it's just like when they see something interesting pop up in like the European or specifically the German market, they sometimes ship stuff through me because those sellers don't want to ship directly to like places outside of Germany or outside of the EU. So right now I've ended up with this motherboard right here, and this is probably the coolest motherboard I've ever held in my hand. So yeah, of course I'm gonna show it off. And before we do that, I want to show off the box a little bit because I think this looks cool. Like it, I always like when things come in the original box, and I think this one looks pretty cool. Just if you look like here, I want to take a bit. Okay, there's nothing on this side. There's more stuff here. We do have this section on the back with all the different things. Could just like, yeah, if you want to read stuff, just pause, I guess. More stuff on the side. And yeah, let's open the box up, shall we? We have more stuff in here. Really, really nice. Really, specifically this part already looks really cool. And then like shows off the VRM. And here's the board. So I'm gonna take this out of the box, which is probably gonna be pretty hard one-handed. So yeah, I'll mount the camera and then take it out of the box. So here we are. It's still a bit out of frame. But yeah, here we have the board. Let's ground myself real quick on an outlet so I don't break this thing. And yeah, let's take it out of the box. It's a bit stuck to the frame. There we go. Let's see what else we get. So this box is mostly empty, and we get I/O shield. Open already. Is it? Okay, DVI thing stuck in there. Interesting. We get SATA cables with the really nice kind of SATA cable. Nice. Then there's nothing else in here, and then we have this box which has a manual in it. We're gonna take a look into this manual later because it describes what all the buttons on the board do. We have this, which is, this is a cool thing. So you can see it from this, it's pretty obvious what it does. You can screw this onto the motherboard, and then you have like a bracket that you can screw GPUs into when you lie the board flat. So yeah, you can, I guess you're supposed to put it down on like a little box or something. Screw this thing, like these two screw holes go into two of the screw holes on the motherboard, and then you can install your GPUs in the board without having to use like a test bench. So we have a driver CD, installation guide. I guess I know how to set up a motherboard. DisplayPort and HDMI port covers. This thing has It has an HDMI port. It has a mini display port. It doesn't have a full-size display port. I wonder why this is in here. Like, that's a full-size display port cover. We have an SLI bridge, Crossfire bridge. This thing's really cool. The Gigabyte G connector. This is for all of your front panel connection thingies. You put the cables into this, and then you have like this one big plug that you just put into the motherboard. Really, really convenient, especially because on most motherboards, this should be the same pin out, so you can use this on other motherboards as well, which makes it just really convenient because you just have one plug, take the front panel out, put it back in when you're like swapping the motherboard or something. And then we have, what's this? Is this a sticker or something? Oh yeah, it is. It's a Gigabyte SoC sticker. Nice. And then we have these little multimeter probes. These, well, you can see these are meant to be connected to the motherboard, and then you can plug your multimeter probes into these, because the board has a lot of built-in voltage measurement points. I'm gonna take a look at those too, of course. So that's the accessories. I'm gonna keep the menu here to show some of the functions of the board off later. But let's put the packaging away for now. Let's put my trusty mousepad down and let's take a look at the board itself. So it just about fits the frame. So, right here is the Gigabyte GA Z170X-SOC Force LN2. This is like when Gigabyte's engineers sit down and go, how can we make the absolute best overclocking motherboard? And that's the result for Z170. So this board does a lot of things, so let's get into that. So the first thing you'll notice, there's only 2 RAM slots. So this is using a single DIMM per channel configuration, which you usually know from ITX boards. But yeah, for extreme overclocking boards, this is a pretty standard thing, because having just one DIMM slot in each memory channel gives you a lot more frequency headroom. Like, even if you're not using the extra slot, just having 2 slots, like having one of them just be there, not having a DIMM in it, already worsens your maximum frequency that you can achieve, because the unterminated contacts inside the slot cause interference, and it just adds extra distance. Like you can see these slots, not just saving space on the one that's farther away because there's no extra slot in between, they're also really, really close to the CPU. On a normal motherboard, they would be like over here or something. So they are like physically as close as possible to the CPU, so that there's as little distance for the signal to travel as possible, therefore the best kind of frequency. There's also another thing that you might notice pretty quickly, that's also kind of related to that. These mounting holes are not the standard Intel mounting holes. These are the AM3 mounting holes, actually, I think. And that, again, is done because the normal Intel mounting holes would be a bit wider and a bit more in this direction of the socket, which would go right in the middle of all of these memory traces. So in order to get shorter and better memory traces, they'd actually move the mounting holes around to AM3, which yeah, can actually be a problem if I were to attempt to run this board, because I don't have any water blocks that mount AM3. The only thing that I have that mounts AM3 is my phase change. Yeah, interesting. Actually, for the Z170X-SOC Force LN2, I think Gigabyte just did away completely with mounting holes. I think that one straight up didn't have mounting holes. There was a normal non-LN2 version that did have mounting holes, but I think the LN2 Z97 just straight up didn't have mounting holes, because, I mean, well, your CPU LN2 port is usually heavy enough so that doesn't fall off, so gravity mounted is. For the same reason, they wanted better trace length, but apparently that might have been a bit too much, so they chose to use AM3 mounting holes instead. Then, we're gonna get into the VRM later. we have a slot spacing that is usable for 4-way GPU overclocking. So I don't think it actually does 4-way SLI, I think it only does 3-way, because this last slot here is only on 4 lanes. These two are on 8 and this one's on 16, though I think this also gets switched to 8 if you plug a card into one of these slots. But the last slot is only 4 lanes. Like physically only 4 lanes, which usually, as far as I know, SLI needs at least 8 lanes. So it might be that you can only run 4 GPUs in Crossfire, because Crossfire is fine with 4 lanes, but SLI usually isn't. You can use different SLI order to get around this thing, which might enable you to run 4 GPUs in SLI here. I just don't know how if different SLI order is HW bot or 3D Mark legal. So yeah. Then what's the next thing? There's so many things. Well, we have a switch here. That's a BIOS switch. This is it's a gigabyte board, so of course it has dual BIOS. The 2 BIOS chips are right here, and what exactly does the switch say? Single BIOS, okay. Yeah, so this is the single BIOS switch, because there's a different switch on this board that also does something to the BIOS chips. So this is the BIOS mode selector. So gigabyte boards normally have a function to automatically switch their BIOSes, which both my Z370 Gaming 5 and my B550 Master also do. The difference is, this one has the switch, which can disable the automatic switching. My other 2 boards don't, and that can cause problems, because when you want to push something like really, really aggressive memory settings, your board might fail to post a couple times before it gets it right. If that goes over, let's say, 5 times, the board might decide that, oh, we're having problems, we're switching to the backup BIOS. You don't want the board doing that, because the backup BIOS won't have any of your settings saved. Neither will it have any of your profiles. So that's what you can use the switch for. That forces the board to just use one BIOS. And then there's a different switch where you can tell it which of the 2 BIOS chips to use. Then we have 2 USB ports, which I think are exclusively just for that. The board comes with this test bench brace. So that's not the only thing that they thought of. So in a test bench, you usually don't have any front I/O, except maybe like a button or something, though you don't need that here. You have a power button right here, and somewhere along here is also a reset button. But what most test benches don't have is front USB. So usually the front USB things, like you can see, we actually have 2 times 3.0 here. And do we have a 2.0? Yeah, there's a 2.0 USB here. But only one, so I think the other USB I/O went to these ports, which is just USB ports that you can use when you have the board in a test bench, which pretty cool if you ask me. Then we have a supplementary 6-pin power connector, which adds extra power headroom to the PCI Express power. So usually each PCI Express slot is rated to up to 75 watts, and if you run 4 GPUs like this board is kind of designed for, well, that's 300 watts of PCI Express power. Your 24-pin, if you use it in 20-pin configuration, I think only has one 12-volt cable, and if you use it as a 24, I think it has 2. That's not that much for 300 watts. So that's what this thing is for. You plug this in, and basically it adds 3 more. Like, this is not a spec 6-pin. This is technically out of spec, because a normal 6-pin I think would be 2 12 volts, 1 sense, 3 ground. This one is just 3 12 volts, 3 ground. So yeah, this adds extra PCI Express slot power so that you don't overdraw your 24-pin. Because like, kind of a misconception that I kind of hear is that, oh no, your PCI Express slot is gonna burn out if you overdraw it. No, the slots will be fine. Your 24-pin is gonna be the problem, because either the cables on your PSU side will burn through, or the little pins inside the 24-pin connector will melt or burn. That's the weakest link. That will usually go up in flames if you have problems. And then we finally get around to this section, which is the work section, the Overclocker's Paradise section. I don't know what Gigabyte calls it. This is the cool section of the board, let's call it that. So let's turn it around a bit, so I have an easier time showing things. So around this section of the board, which, I mean, you kind of get it, like with the USB here. The board's kind of meant to have it like this. Like if I'm sitting where I'm sitting right now, like here, you're kind of meant to have the board like this, because then you easily have access to this, and yeah, that's pretty much it. Like, this gives you access to this side of the board. And here we have most of the overclocking playthings. So we have a ton of buttons. We have all these little voltage measurement points that I meant. Like we have 5 over here, 4 more over here. That's where you put these little probes into. And then you can put your multimeter into the probe extensions and measure the voltage of pretty much any voltage rail on the motherboard. And of course we have a postcode. Like your postcodes are like the most common overclocking feature, I think. Sometimes you only get debug LEDs. I really prefer postcodes because debug LED is like, oh yeah, they tell you, well, which component has the problem, but like, you usually don't need debug LEDs to figure that out, and they don't really help you diagnosing which problem that component actually has. So having a postcode, really, really useful. I just like having postcodes. Also just for giving you the peace of mind of knowing what the board's doing right now, because like each postcode corresponds to a different thing that the board does during the boot up process. So you can kind of tell like, oh, this postcode happens a lot when like I have bad memory settings, or like, oh, this happens when like the CPU is having problems, or this kind of looks like it can't load Windows or something. But yeah, like a postcode is a rather standard feature for an extreme overclocking board, since they do appear on non-extreme overclocking boards. For example, my Z370 Gaming 5, it's not even the highest one in the gaming brand, and it's not the Z370 SOC. That one still has a postcode. Then we have a pretty cool switch. This one can disable the PCI Express slots. So each of these switches corresponds to one of the PCI Express slots. And if you put them in the off position, that just disables the PCI Express slot. Now, why would you do that? Basically 2 reasons. The first reason is, one of your graphics cards running an SLI or Crossfire is having problems, and you want to figure out which one it is. And I mean, problems with multi-GPUs, yeah, pretty common, happens a lot, very big headache. And this kind of helps you with troubleshooting, because you just start disabling the slots until the thing boots up, and then you know, oh, that card's having a problem, so you might remount it, or like might check for hardware faults, because like when extreme overclocking, if stuff breaks sometimes, that's just a thing. You have to be, yeah, I mean, it's not that something will die, it's just that there's the highest chance of something dying when you extreme overclock. So it can help you troubleshooting. What it can also do is if you're running a multi-GPU setup, and you're done with like your multi-GPU scores, but you still want to get some single GPU scores, but you don't want to like tear the entire bench down. Then you can just disable the slot that the GPU is in that you don't want to use, and there you go, now you have a single GPU setup. Without having to do anything else, just flip a switch. So yeah, that's kind of the 2 use cases that I can think of for these. Then, shall we get into the buttons? This button says memsave, and I think this is the point where we need the manual, because the manual should have all the button descriptions in it. So I don't want to say something that's wrong, I'm just going to consult the manual right away, because there is a lot of buttons in this thing. Let's see, is there... just how to install a CPU, how to install RAM, we know that. Here's how to install the extra brace they give you. Onboard switches and buttons, here we go. So, it goes into the switches first, so let's, yeah. So, we already talked about this, the single BIOS button, which, yeah. That's just, yeah, I already explained what it does. And then we have the BIOS switch button, which is this left one here, it should be, if I'm getting this right. So this is the button that, the switch that chooses which of the BIOS chips you use. So provided you switch this one into single BIOS mode, you can then use this switch to change which of the BIOS chips you're actually using, which it also has its uses. Because like you can test different BIOS versions, for example, very, very easily, because you switch to one chip, try a specific set of settings, then switch to the other chip and put the exact same settings in, and then see which one performs better. And then it also says we have, oh yeah, those are just LEDs for which chip it uses. Like there should be an LED corresponding to each BIOS chip. Then quick buttons. So power switch, this one, and the normal power switch. Reset switch, this blue one. CMOS clear switch, this one on the left here. And then CMOS battery switch. So this one probably disconnects the power from the CMOS battery, so you don't actually have to remove the CMOS battery to completely reset your CMOS. Why you need a CMOS battery and a CMOS clear button, I don't really know. But I guess if the CMOS clear button doesn't work, you can press the battery button to like really make sure. Then, yeah, this one already went into this for PCI Express slot disable, and here we have the overclocking buttons. So this is the interesting part. So I'm just gonna go read to the camera if you wanna pause this and read it yourself. And let's review the buttons. So CPU ratio down button, ratio DW. I guess it's gonna. Yeah, like, which one is it? Ratio DW. So it's this one, down. And then ratio up is this one. So this one can change your CPU ratio on the fly. Like while you're booted, while you're in Windows, you can change your CPU ratio with these. And then we have very similar looking buttons. These are basically the same, but for your base clock, your BCLK. Same thing, you don't have to go into BIOS, you don't need any extra software, you can just press these buttons, and because this one should be a clock gen, this should have a clock gen under it, which these buttons probably just directly interface with that, and you can change your BCLK on the fly for CPU validations or even RAM validations, whatever you want to do. Then gear button, this one. This changes the increment of your BCLK, so from 0.1 to 1 MHz of BCLK adjustment. Also very useful, because you don't, like if it's 0.1, you're gonna need a lot of presses to get to like 110 BCLK. Yeah, and then the OC tag button, the tag button. This button allows users to load their customized settings using the Save to Tag profile created in BIOS setup, so you can apply your custom settings after clearing CMOS. So, should you use the clear CMOS thing, you can have a special profile set in your BIOS, and if you press this button, it just loads that BIOS, so you don't have to go back into the BIOS and configure anything. That's also pretty cool. And I guess this also works without clearing CMOS, so like you press this button and it applies that profile, it just does. So, I guess that would be cool. Then we have the OC ignition button, which I guess is this lightning button right here. The OC ignition feature maintains power to your motherboard and connected components while the system is shut down. After pressing this button, be sure to press the power button to take effect. Please note that the system will not be able to enter S3 mode if this feature is enabled. So that sounds kind of like a handful. So basically, you can power up things without actually having the system like run, without having the CPU like do anything. Kinda like the same, yeah, I guess it's the same thing as unplugging your 24 pin and shorting the PS on pin. Like it provides power to your system, but it doesn't post. Like it turns on but doesn't do anything. I guess that's what it does. So like I think Gigabyte said, like on the new, I think on the Tachyon, they made a marketing thing about, oh, it's good for testing custom water loops, which, I mean, yeah. Don't really know like what applications it would have for extreme overclocking. Yeah, not actually entirely sure, like troubleshooting basically, I guess. And then we have the OC turbo button. Press this button to load the most optimized gigabyte overclocking configuration for your processor and memory. So, yeah, this might just load a pre-made profile. It might be the LN2 mode, but it doesn't sound like it's the LN2 mode. Yeah, it doesn't sound like it's the LN2 mode. So this probably just loads a pre-made profile. Kinda useless. Like, it's an extreme overclocking board. Like, it has all these features so that you don't just press a button and call it a day. But I get that it exists. Like, it's better having something and not use it than not having it and needing it. So then, direct to BIOS button. Which one actually is that? DTV, it's one of these. Yeah. No, wait. There's the reset switch. Reading all the things on here is kind of... oh, this one, the middle one. Direct to BIOS. I mean, it kind of says in the name. You press this, you go to BIOS. I guess you don't have to spam delete while it modes up. Memory save mode. This one, I already talked about it. Oh, I mean, began to talk about it in the beginning, then got the menu. So, yeah, I'm just gonna read the description again. Pressing the memory save button engages a failsafe mode that allows the system to boot in a safe memory configuration, regardless of the DIMM speed or CAS rating. The system will reboot after completion. Note, engaging memory save may impact system memory performance. So basically, what this will do is you press this button, and your system boots up with probably like the JDEC bin of your memory, or like the lowest JDEC bin there is in general, without wiping your memory settings from the BIOS, I think. So if you have, if you dial in some memory settings that don't work, that don't even post, you can press this button, get back into BIOS without losing like all your settings. Because like sometimes you don't save it to a profile, and if that happens to you, then well, you're gonna have to read all your settings. With this button, you just press it, memory goes back to JDEC, but you still get to keep your settings, is what I understand here. Settings lock button, set lock, middle one. The Gigabyte settings lock button allows the system to automatically remember your last successful settings even after clearing CMOS. With one touch, the settings lock button can quickly revert to the previous good settings, a very useful tool for overclockers turning their BIOS to perfection. So kind of similar to the memory OK button, it's just the last configuration of settings that resulted in the system posting. Doesn't exactly have to mean that it's stable, but it's like it loads the last configuration that you were able to post with, which is also kind of like for these moments where like, oh, I changed something and now it doesn't want to post anymore. So that's what this button is for. And then we have the OC trigger switch, which is this one probably? Is it? Just want to make sure on the menu. I mean, it's a switch, so yeah. This switch allows the overclockers to jump between low and extremely high frequencies in an instant. After remaining at a low frequency during system boot and OS optimization, the overclocker can engage the trigger switch to instantly hit the target frequency, save their score submission, grab a screenshot, and watch the records tumble. This sounds pretty cool. Yeah, a target frequency set in BIOS setup for overclocking application, save frequency. So basically, that switch sets your CPU ratio down to the lowest ratio available, which is cool for a multitude of reasons. First off, you can set the CPU ratio down with, like, again, without using any extra software or going into BIOS. You can set this down while like cooling down your pod, because lower CPU ratio means it's gonna consume less power, kick out less heat, which is gonna save you some liquid nitrogen and also gonna make it a little bit faster to cool down. And of course, if you're like really pushing the frequency, where like just grabbing a screenshot might be enough to crash your system, you can use this and like get whatever score you want. I mean, for CPU-Z validations, well, you kind of have to be at the frequency while taking the screenshot, but for things like SuperPi, once SuperPi is done running, you can flip the switch, your CPU ratio goes down, and you're at basically no risk anymore that this thing is gonna crash. Like, your score is basically safe because the system will probably not crash after you flip this switch, which is a thing that can happen. It's also a thing that has that's a bit of an annoyance for these 260 corp that we're doing, because the test shows the score within the benchmark that's still running. So if you're like just enough stable to make it through the benchmark, you're now racing against the clock to take your screenshot, because you can't close the benchmark window because you need to have the score in the screenshot, but the benchmark just keeps running in a loop in the background while showing the score. So yeah. Well, I guess I could also just have a shortcut MS Afterburner to like do effectively the same thing, to just like go back to base clock once that's done. But yeah, so that should be all the buttons on here. So time to look at the VRM, shall we? So let's flip the board around. Let's take a look at the VRM. Like, I already kind of know what to expect. I mean, it's a Gigabyte board. There's one specific VRM component that Gigabyte was really, really, really a fan of. I even had the same VRM component on my AX370 Gaming K7, and if you remember that board's VRM, you know what I'm talking about. Plop. That's the VRM off. That VRM heatsink off. And yeah, it is the one and only IR3553, a 40 amp smart. Is it a smart power stage? It is a power stage. I'm not entirely sure if it's a smart power stage, but it's made by IR. It's basically it quite literally is a smaller IR3550, because it's 40 amps, not 60. And the packages are a bit smaller. I think the package is kind of pin compatible actually with the 3550. Like, there's some motherboards and GPUs where they have the footprint for the 3550, but then only a 3553 on it. So like part of the pads is actually left empty. But yeah, so this is using 40 amp power stages. Again, don't know if it's actually smart power stages. And you might say, oh, that looks like a lot of phases. Actually, that's only an 8 phase for the vCore. The rest is like iGPU and SA and SO. Like, Gigabyte even uses 3553s for the memory VRM. Like, they use, there's another one, 3553. They use these for like everything. Because Gigabyte at some point bought a lot of these, and they did use it on like basically everything. So yeah, and 40 amp power stage might not sound like much these days. Like, these days you can get, I mean, 60 you could get back then, but these days you can get 70, 80, 90, 100, and 120 amp smart power stages. So yeah, compared to those, the IR3553 isn't all that great. But you need to remember, this is Z170. This was made to push the 6700K. A 4-core, 8-thread CPU. And 8 phases of IR3553 is completely fine for that. Then the 7700K was pretty similar story. And then of course we got the 8700K and the 9900K. Now that's a bit different, because, well, it's 6 and 8 cores for those. Though back then Gigabyte couldn't really know that. I'm pretty sure the VRM would still be fine for that though, because like, it's an 8 phase of 3553s, and I had a 6 phase with these on my X370 Gaming K7 and my overclocked 1800X, which pulled like 180 watts, which is like around 8700K level. The VRM was fine. So this has 2 more phases. It has a better looking heatsink, though I guess it could be better. They could have put heat pipes into that and then like extended the heatsink somewhere. Like, it could be a more substantial heatsink. This empty thing, yeah, it actually could be a lot better. It's not the worst heatsink I've ever seen though. But yeah, like, you get 2 more phases, and then like 9900K overclocked, well, it might be a bit much. I think you can do like 250 watts on that. It should still be fine. Should be fine. Though it might run a bit hot. But for 8700K, this one should no problem, should work. 9900K, I'm not so sure. But yeah, so you can actually see the VRM configuration on the back a little bit better. I hope you can see this on camera. But the vCore portion is right here, this power plane. And each of these corresponds to an IR3553. So you can see the first two ones, probably VCC SA, VCC IO, like the minor things. Then we have 1, 2, 3, 4, 5, 6, 7, 8 that go into vCore, and another 4 that power the iGPU portion of the CPU. So that's the split. So 8 core, 4 iGPU, and then 2 for minor rails. So yeah, still a total of 14 power stages, which does look very impressive, though like slightly over half of that is core. Yeah, and then as far as for the PWM controller, we actually have 2 PWM controllers over here. And they should both be the same. Yeah, they're both IR35201s. I guess one's doing core, the other one's doing iGPU and the minor rails. So, yeah, I don't actually know anything that much about the controller, but, well, what else would I say except like, oh, it has this many phases and this switching frequency and that stuff. Not really all that important. It's gonna be good enough. It's an SOC LN2. So if you really want, look up the datasheet. IR usually is pretty good at providing datasheets for their parts. So, I think I've actually talked about most things about the board. So, yeah. Conclusions then. I really like this thing. It is such a cool board. Like, yeah, it is cool. And like, if you know me, you know that I'm kind of a fanboy for Gigabyte and especially the SoC stuff. I just kind of really like their stuff. Also, I really like the aesthetic of this. Like, these days you don't get this anymore from Gigabyte, this like black-orange color scheme. I really like this color scheme. I guess you can call it the Buildzoid color scheme. Because he might be one of the last people that still use black-orange as a color scheme. Like Linus Tech Tips abandoned it a long time ago. Gigabyte abandoned it for, well, RGB, the same as everyone else. So it's kind of like, yeah, this is kind of what RGB did to us. We don't really get color schemes like this anymore, where like the RAM slots or the PCI Express slots actually have proper color in them and not just different shades of gray and silver. Not meaning that I dislike RGB, like I kind of actually really like the aesthetic of my Z370 Gaming 5, but I also really like this, because this, I think this just looks classy. Like RGB is flashy, this looks classy. This looks like business, like this board means business, and it does. It doesn't have to bolster itself with lots of LEDs. It doesn't need any RGB stuff, it doesn't need to glow. This board just looks good by itself without any of that. So yeah, I really like the color scheme. Yeah, and of course I love all the extra stuff. Like I would love to have a board with like this. I was actually thinking, when I first saw the board, I was thinking, oh man, this is so cool. This is so cool. And after like reading into what it can do, I would love to have this board. Which I think Spicer paid 140 euros for this, I think. Which isn't too bad. Like 140, that's pretty good. Like I was looking into getting a Z170 OC formula for like 150. Which I've now decided against because I got a better offer for something else that you might see soon once it gets sent out. But yeah, so the main reason is just like, these ones are kind of rare. Like, you can't find Gigabyte SoC LN2 stuff all day. Like, they are pretty rare, that's also why, like, these boards are really cool. But you don't see them used a lot, because there's just a lot more like Aces, Apexes, or OC formulas like out there. SoC stuff is kinda rare. It doesn't mean that it's bad. It's like, this board probably like kicks ass. It's just like kinda hard to get. And actually, I think this one wasn't even retail. Yeah, I think this one wasn't even retail. I think the only SoC LN2 board that Gigabyte made that was retail was the Z97 one, the one without the mounting holes, if I remember correctly. I think every other SoC LN2, like the non-LN2 ones were always retail, but the LN2 ones, I think you could only get from Gigabyte directly. So that's like the Z370-LN2, or this one. Like, I don't know if there was a Z270 one. But yeah, like I think the Z97 SoC LN2 was the last time you could buy an LN2 focused Gigabyte board before the Tachyon, which is a long time. So considering that this one, as far as I know, wasn't retail, pretty hard to find. Pretty hard to find, and for a good price like that, that's not always guaranteed. Some people might be more unreasonable and want something like 300 euros for that, and at that point I'm going, no, an OST formula costs half that much. And yeah, an OST formula doesn't have all the functions, and it has 4 RAM slots and everything, but the Z170 OST formula is still an overclocking focused board that's pretty good. And I would settle for an OST formula. Yeah, but I didn't settle for an OST formula. I set it for something else. I did get a board, and I pretty much only got that board because it was a lot cheaper than I anticipated. But I'll talk about that board when I get it. The other reason why I kinda don't think I'm ever gonna end up with a board like this is, so if you look at the socket, gonna be careful here not to break it. So this is an LGA 1151 socket. An 8700K or 9700K do fit into the socket. You can put them in. There will be no problem with that. But once you turn it on, you're gonna have a fire, because from LGA 1151 on Z170 and Z270 to LGA 1151 V2 on Z370 and Z390, Intel changed some of the pin out of the socket. So for example, they famously moved the socket occupied pin like one to the left, so that when you press the power button, the Super I/O chip checks that pin if it's pulled to ground, and when it's not, the Super I/O chip goes, oh, there's no CPU installed, we can't start. But there is a CPU installed, the pin just goes to the wrong place. So that's why in a lot of these Z170 to Coffee Lake conversion things, you either short together 2 pads on the CPU, or you go to the Super I/O chip, which actually, where is the Super I/O chip on this thing? Is it this one? It might be this one, or might be somewhere else under this. Or maybe it's this. Maybe it's that. Like usually I think the Super I/O chip is around here, so it might be that one. Which kind of sucks on this because it's not accessible. But yeah. Not only do you need to do like short that pin together, depending on what motherboard manufacturer you also have to isolate some pads. Now, as far as I know, on Asus boards, you don't have to isolate any pads. On ASRock boards, you have to isolate some pads on some motherboards, but I think you can get away without doing it, but there is a risk that it might burn and short out some pins. On MSI boards, I don't remember actually, and on Gigabyte boards, you need to isolate like a lot of pins, like basically this entire corner right here, because I don't entirely know why, but a lot of pins in this area will get shorted and burn, and like your CPU will be destroyed by all the heat that gets generated by this giant short circuit. Like the socket's gonna be dead, the CPU's gonna be dead, you're gonna have a really bad day. So you need to isolate a ton of pins on a Gigabyte Z170 board to use it with Coffee Lake. Which is the other reason that I'm going like, yeah, probably not gonna do this, because I'm gonna keep my 8700K. Like, I only bought that board because it was really cheap. I don't have that much money to throw around. So yeah, I'm not gonna like buy a CPU. Though actually Spicer did offer to like finance a 6600K so I can test this board. Like I have DDR4 RAM. So he might still do that. We might still get to run the board with like a 6600K that I guess he then gets to sell for a profit maybe. or like keep if it's a good one. But yeah, like I would keep my 8700K for my test bench, and getting a Z170 board from Gigabyte for that is just, it's really hard to convert a Gigabyte Z170 board to Coffee Lake. So that's kind of the second reason. So these things are really hard to get, and they're also pretty hard to mod into accepting Coffee Lake, which are the two main reasons for why I love this board. I would love to have one of these and use it, but those are the two main reasons why I'm probably not gonna. And I think with that we can end the video on this really, really cool board. It's already 43 minutes, but honestly the board kind of deserves it. This board is cool enough to deserve a video that length. I'm not even feeling bad about having it this long. This is, at the time of filming this, the coolest board I've ever had the honor of witnessing and, seeing in real life. And I am sure Spicer will have a lot of fun with this board. Like, he's also a guy that really likes Gigabyte SoC stuff, which I support. So, yeah, I trust he will have a lot of fun with this board. And yeah, that's pretty much it. I hope you love this board too, because if not, we're gonna have a problem. Just kidding. But yeah, really cool board. Like, especially the fact that this wasn't retail. Like this, if this wasn't retail, Gigabyte must have handed this one out to someone. Like I think it came from Romania. So I don't know, maybe there's an overclocker there that gets stuff from Gigabyte, or that person also got it from somewhere else. And like, to get this board, to have a chance to like have this board in my hands, to even like get the packaging and everything, really cool feeling. It feels really cool. I hope this came across in the video. But anyway, I think it is time to stop now. So thank you all for watching. I hope you enjoyed, and until next time, goodbye.